Okay, class, welcome to the next lesson in 8th grade Eureka Math. We're in Module 4. This is lesson 26 called Systems with Parallel Lines. So in lesson 24 and 25, we'll be talking about systems of equations and how to solve those systems of equations. We've checked how to see what the solutions are by graphing, and where the equations cross, that is the solution that is true for every equation in the system. Well, today we're going to talk about what happens if we have parallel lines in our systems. So we're going to talk about systems with parallel lines and how that kind of changes how the solutions work. So you'll need pages 321 through 333 of your Module 4 workbook. You will also need all your math tools today. And as my reminder at the beginning of every lesson, you are in control of the speed of this lesson. So if I'm going too fast and you need more time to write down your notes, simply pause your video and take the extra time to write down your notes. If you understand what we're doing, you can move ahead. If you need to go back and rewatch anything, you have that control. So use the control that you have so that you succeed. Let's start our lesson like we do with vocabulary, and we have 3 terms today. 2 of them we've seen before in lessons 24 and 25. The first vocabulary term is system of equations. Now, as a reminder, a system of equation means linear equations that are related to the same situation. So these are systems of equations that are connected to the same circumstances. Like we saw how we can use systems of equations to see how basketball games work. We've talked about how we can see systems of equations about how fast people move to control who's going to win and when people will catch up. A solution to a system of equations are coordinates that make all system equations true. That's what we learned in lesson 24. In lesson 25, we added that the solution is the point where the equations intersect. So a solution are the coordinates that make the equation true, or where the lines intersect, where the lines cross. Which means you might know, if I told you this lesson was about parallel lines, you might be thinking, wait a second, Mr. Baylor, parallel lines never cross. So what's this about the solution? Well, let's throw the definition of parallel lines on here just to help us out later. Parallel lines are lines with the same slope, identical slopes. Same slope, but with no shared points. They share no points, but they have the same slope. That is the definition of parallel lines. Same slope, but no shared points. So those are the 3 vocabulary definitions we have. Today, we will see how a system of equations with parallel lines has no solution. And you probably figured that out. You probably knew that already, because parallel lines never cross. They can have no solution. Because remember, the solution definition was the point where they intersect. And parallel lines never intersect, so parallel lines have no solution. We're going to see that today. We're going to graph some parallel lines, and we're going to observe how they have no solution. I do want to teach you one more process today about how to know if equations are for parallel lines. How to know if equations are for parallel lines. So you can graph the equations and see if they're parallel, or this is a process to just check if they're parallel without graphing. So what you do, step 1, change all your equations to slope-intercept form. Because remember, we need to check to see if slopes are the same. Our definition of parallel was same slope. So to know if the slopes are parallel, we change it to slope-intercept form. That's the first thing you do. Change equations to slope-intercept form. That way we can see the slopes. Now you have a choice. If you have the same slope and different y-intercepts, the lines are parallel. Same slope and different y-intercepts, the lines are parallel. If you have the same slope and the same y-intercept, that's the same line. Same slope and the same y-intercept means it is the same line. So change equations to slope-intercept form and then compare the equations. If the slopes are the same and the y-intercepts are different, that's how you know something is parallel. If the slopes are the same and the y-intercepts are the same, it's the same line. If the slope is different, it's not parallel. Different slope means not parallel. Let's practice this a little bit with some exercises. We're going to practice checking if lines are parallel. And remember, if they are parallel, there is no solution to the system. So let's check this out. We're going to do some of the exercise. I think we're going to skip some throughout just to keep the lesson a little bit shorter, but let's see what we got. Exercise 1, sketch the graphs of the system. So we have two equations. We need to sketch both graphs. So we have y equals 2/3 x plus 4 and y equals 4/6 x minus 3. Well, to do this, let's say here's going to be our red equation and here's going to be our blue equation, just so that we can see the differences when I start to graph. So remember, for y equals 2/3 x plus 4, I need the y-intercept and I need the slope rule. The y-intercept goes plus 4, so the y-intercept is 4, which means the y-intercept is 0, 4. M is 2/3, which means we go up to right 3. So let's graph that. So we start with the y-intercept, 0, 4, right here. And then we go, that's our first point. Then for point 2, we go up to 1, 2, right 3, 1, 2, 3. So this is our other point. So we have our 2 points. And then we connect them as precisely as we possibly can. That looks pretty close to me, so I'm going to draw my line. There we go. That's our red equation. Now let's graph the blue. Let's graph blue. So for blue, we have y equals 4/6 x minus 3. So again, we need the y-intercept and we need our slope rule to find 2 points. The y-intercept is -3, so the intercept point is 0, -3. Our slope was 4/6, which means our slope rule is up 4, right 6. So let's graph our 2 points, connect them to make our line. So we start at a y-intercept, 0, -3. Going a little bit faster because we've done a lot of graphing this way. Now that's our first point. To make our second point, we follow the slope rule, up 4, 1, 2, 3, 4, and right 6, which our second point is right there. Now we graph them. We connect the points we made using the y-intercept and the slope rule. That looks pretty spot on to me right there. So I'll draw my line. And there's our red line. There's our blue line. Now, so we graphed them. Now let's answer some questions about this. Part A, identify the slope of each equation. Well, I already did that in right here when I made my graph. But let's do that again. So the red slope, remember, was 2/3. And the slope of our blue equation was 4/6. But you might have noticed something like this because 4/6 can be simplified. 4 is 2 times 2, and 6 is 2 times 3. 2 divided by 2 is 1, so that just means 1 times 2/3. So the slope is really just, after we simplify, is 2/3. So what do we notice about these two slopes? They are the same slopes. There we go. And then part B, identify the y-intercept point of each equation. Well, I did that when I graphed too. They're just asking me to write down what I already did, but I can do that. It doesn't take any extra time. Well, slightly, but not much. So the y-intercept for our red line, remember, was 0, 4, because we did that right here. y-intercept for the blue line right here, 0, -3. And then, so those are our y-intercepts. Are they the same or different? They are different because 4 is different from -3. Is there a part C to this? No. Okay, so I'm going to add a little part C to this because here, what we have right here, we see same slope, different, I'm going to add different y-intercepts. Same slope, different y-intercepts. So if we go back to our note page and I show you the list of what we do, equations and slope-intercept, if we have the same slope and different y-intercepts, well, that means the lines are same slope and different y-intercept equals parallel. So we can say that same slope, different y-intercept means parallel lines. That is what they're trying to get you to see. Same slope, different y-intercept means parallel lines. So you can do it with math by looking at the slopes and looking at the y-intercepts. But, I mean, when we graph these, and you saw the red and the blue line, you probably saw, wait, these look pretty parallel. It's always good to confirm mathematically that they are parallel, but you can see with your eyes that these are most likely parallel. Let's look at another one. Let's see what else they got for us. So we got to sketch the graph of this system now. So let's sketch it now. Luckily, they have both in slope-intercept form for us. We just need to graph them. So y is -5/4 x plus 7. So this is going to be our green equation. So green right here. And let's use orange for that one right there. So again, we need the y-intercept and we need our slope right there. So the y-intercept here is 7, which means the point is 0, 7. M, the slope, is -5/4, which means we are going up -5, right 4. Remember, up -5 is the same as down. Let's graph this. So y-intercept 0, 7. So 0, 7 is the y-intercept. Follow the slope rule. Up -5, right 4, which means just down 5, and right 4. 1, 2, 3, 4, 5, and right 4. So that's our second point. To get our line, we connect the points just like that. That's pretty close. I think I'm a little bit off, but we'll live with that because I did it in ink, and you kind of have to live with it. So that's the first equation in our system. Let's do the next one. Y equals -5/4 plus 2. So this time B is 2, which means the intercept point is 0, 2. M is -5/4, which again means up -5, right 4. So let's make our 2 points. We start with this y-intercept, which is 0, 2, and we follow the slope rule to find our next point. Up -5, which means down 5, right here, right 4, so right here. And to graph them, to graph the line, we connect the points, which looks like it could work right about there. Oh, went a little bit. There we go. That's what we got. Now, these look pretty parallel to me. Well, let's confirm it by using what we talked about in our notes. First, they want the slope of each equation. Okay, so let's find the slope of our green line. We said it right here. M is -5/4. And the slope of our orange equation, M, is -5/4. So what do we notice about these? They have the same slopes. Good. Now, part B, identify the y-intercept. So the y-intercept of our green equation, was right here 0,7. So y-intercept was 0,7 for the green. Y-intercept for the orange equation was 0,2. Are they the same or are they different? Well, 7 is different from 2. So these are different y-intercepts. Different y-intercepts, which means same slope, different y-intercepts. Back to our note page. Same slope, different y-intercepts means parallel lines. So they looked parallel in our graph. Now we know they are parallel because they have, remember the definition of parallel also, same slope, no shared points. Same slope and no shared points. So these are parallel. They look parallel when we graph them, and they match the parallel definition that we did in our notes. Let's see what the next exercise is. Exercise 3. Oh, they want us to do it again. How about this? How about you do it yourself? How about you pause the video a little bit, do exercise 3 on your own. It's the exact same thing as exercise 1 and exercise 2. So try number 3, pause the video, try number 3, and then unpause the video when you're ready to check your work with mine. Okay, so hopefully you paused the video and tried number 3. Let's see how you did. Let's see how you did. So we have I'm going to do a pink equation and a brown equation just to make things easier to see. That's why I like working with different colors. Also, I think it helps you a little bit. So let's find our information for our pink equation, y equals 2x minus 5. And it's already in slope-intercept form, so we just need to identify the intercept, identify the slope if we want to graph this. So when you did the intercept, you should have seen the y-intercept is -5. That -5 means -5. So you should have got the point is 0, -5. And the slope is 2, which you know from other lessons really means 2 divided by 1 makes 2. So you know the slope rule is up to right 1. So when you graph this, you should have started at 0, -5 right here to make your first point. Then you start at the intercept and you follow the slope rule. Up to right 1. And so that is your second point. And to graph the line, graph our pink line, we just need to connect the 2 points, which I'm going to try to be as precise as I can. It's kind of hard to, I can't put my head over, because if I put my head over the paper, I'll block the camera. But I think that's pretty good. Now let's graph our brown equation. Y equals 2x minus 1. So you should, this is, remember, where you're checking the work that you did independently. You find the y-intercept first, which is -1, which means the y-intercept point is 0, -1. Then you find the slope rule. The slope is 2, which, just like the pink line, means 2 over 1, which means up to right 1. So it's the same slope. I think you can already predict what our conclusion is going to be at the end of this page, because you just saw the slopes and you saw the y-intercepts, and you were paying attention for exercises 1 and 2. But let's graph it. Let's check your work. So the y-intercept is 0, -1. So 0, -1 is the y-intercept. Then we follow the slope rule up to right 1. And we graph it by connecting our 2 points, just like that. They look pretty parallel to me, but let's prove it with the mathematical definition. So for part A, it says find the slope of each equation, which I already did. The slope, the pink slope, m equals 2. The brown slope, m equals 2. So m equals 2 for the pink equation, m equals 2 for the brown equation. What do you notice? I notice we have the same slopes. And then Identify the part B, identify the y-intercept point of each equation. So the y-intercept for the pink equation is 0, -5. B equals 0, -5. The y-intercept point for the brown equation is 0, -1. So B equals 0, -1. Are the y-intercept points the same or different? Well, you should have seen when you did the work, -5 and -1 are different. So we have different y-intercepts. So what conclusion can we make when we have the same slope and different y-intercepts? Same slopes and different y-intercepts, remember, means same slope, different y-intercepts means parallel lines. So these lines right here, these equations are for parallel lines. For parallel lines. Well, if you got those same answers, well done. If you didn't, go back and look at what I did to see where you might have gone astray. Okay, so we've seen that we can determine that lines are parallel. But what does this mean about the solutions to our equations? Remember, our definition of solution to a system is where the lines intersect. Where the lines intersect. Parallel lines, by definition, never intersect. They are always the same distance apart. They never cross, which means there is no solution to this system. This system from exercise 3, no solution because they're parallel and they never cross. This system from exercise 2, no solution because they never cross. We can even add it. Parallel, no solution because they are parallel, they never cross, no solution. This system from exercise 1, no solution because they are parallel, they never intersect, a solution is impossible. So parallel lines have no solution. So if somebody ever asks you, what is the solution to this system? You say, no solution, because they're parallel. You say, no solution to this system, because they are parallel. And you say, no solution to this system, because they are parallel. So yes, a system can have no solution. In fact, you can make any number of systems with no solution. Like for exercise 4, it says write a system of equations that has no solution. All you have to do for this one, you remember that all you need to do is you need to write parallel lines. So you write 2 equations with the same slope. So the slope is 3 for this equation. So if you want no solution, you just need same slope, different y-intercept. Same m, different b. And that is how you do no solution. That means parallel. That means no solution. So if m is the same, b is different, it means they're parallel, means no solution. And that's actually answer number 6. So I'm going to skip exercise 5. How can you tell if a system of equations has a solution or not? You check, you ask yourself, are the lines parallel? You ask, are the lines parallel? So if m is the same and b is different, that means they are parallel. If m is the same and b is different, that means parallel, and parallel means no solution. So if they are parallel, there is no solution. That's the only time there is no solution. Parallel lines have no solution. And you check the slope, you check the y-intercept to make sure. Let's practice this without graphing. For exercise 1, 2, and 3, we saw no solution with graphs. What if they don't want you to graph? What if they just give you the equations, like in number 7 and 8 right here? Do these equations have a solution? Let's check. Well, you'll see right now that these are not in slope-intercept form. So our first step is to change them to slope-intercept form. I told you this way back in the notes. Change equations to slope-intercept form. So let's make the top equation green, color code it. 6x minus 2y equals 5. So to change it to slope-intercept, remember I want y equals mx plus b. So let's add 2y to both sides to make y positive, because I want positive y equals. So I get 6x equals 2y plus 5. Let's do minus 5 to both sides with the subtraction property of equality. So I get 6x minus 5 equals 2y. Then I use the division property of equality to divide everything by 2. That gives me 3x minus 5 over 2 equals y, which is, if I switch it around, slope-intercept form. Y equals mx plus b. Now let's do our next equation. Change that to slope-intercept. So we have 4x minus 3y equals 5. Let's check and see what that looks like in slope-intercept form. So I'm going to add the 3y because we want positive y, not a negative y, using the addition property of equality. So I get 4x equals 3y plus 5. I'm going to do minus 5 to both sides. That gives me 4x minus 5 equals 3y after the subtraction property of equality. Division property of equality, divide everything by 3 to get y by itself. That gives me 4/3 x minus 5/3 equals y, which in slope-intercept form is y equals 4/3 x minus 5/3. So now we have both equations in slope-intercept form. Is there a solution? And you have to say yes. And the reason you say yes, the lines are not parallel. The lines are not parallel. How do you know they're not parallel? How do you know this? You look at these and you say, we have different slopes. So they are not parallel. Remember, no solution means parallel, and parallel means same slope. If the slopes are different, different slopes means not parallel, which means there is a solution. Different slopes, 3 4/3, different slopes. I can even underline them for you or box them for you. Different slopes means the lines are not parallel, because parallel means same slope, which means there is a solution. So is there a solution? Yes. Let's try number 8 real quick. Number 8 is asking us to do the same thing. Do these have a solution? So let's change these. They are not in slope-intercept form, but remember, solution is all about being parallel or not, and for parallel, we need to check slope. So let's change them to slope-intercept form. Negative 2x plus 8y equals 14. Well, we want to isolate the positive y, so let's do the addition property of equality, add 2x to both sides. That gives us 8y equals 2x plus 14. Now, division property of equality, we need to divide everything by 8, and that gives us y by itself. Also gives us 2/8 x plus 14 over 8. Now, 2/8 can simplify. 2/8 reduces to 1/4, so we get y equals 1/4 x plus 14 over 8. So that is the first equation in slope-intercept form. Let's do the next equation. X equals 4y plus 1. Now we really just want the y by itself, not the x, so we need to move things around. Let's use the subtraction property of equality, take 1 away from that side, move it to the other side. So we get x minus 1 equals 4y. Division property of equality to get the y by itself like we like. That gives us the y isolated. 1x divided by 4 is 1/4 x. Minus 1 divided by 4, which is 1/4. I'm going to switch it around so that it's easier to compare. And you'll see right there, hold up, wait a minute. Looking at what you know to look at, these slopes are the same. The y-intercepts are different. So we have same slopes, different y-intercepts, which means these are parallel lines. Which means they are parallel lines because these equations have the same slope, different y-intercept, and that means same slope, different y-intercept means parallel, and parallel means no solution because the lines never cross, and a solution has to be where they cross. No solution, the lines are parallel and never intersect. And that's what we're doing today. That's 2 examples. We have one example where there is a solution, one example where there's not. I think there's 2 more exercises, 9 and 10. Well, 9 is the exact same thing. I'll do the work and I'll put my answer online so you can check yours, but we're not going to talk about it now. I just wanted to get you some introduction, do some exercise where you can practice. Let's talk about your work for your independent work today. So if you want to do exercise 9 and 10, go for it, try it, and check your answers with my work that I post on the Google Classroom. But the next page, page 326, is the lesson summary you can look at. So some good points that we mentioned today. First, parallel lines do not intersect, which means the system has no solution. Parallel lines intersect, and so the system has no solution. Also, the definition of parallel line is in here. Parallel line means same slope, no common points. And you can know this by comparing slopes and y-intercepts. So same slope, different intercept means parallel. So that's just a summary of everything I talked about in this lesson. Page 327 is your exit ticket, which we'll talk about last. Page 329 and I think page 330, yep, are your homework helper. If you want some more questions with some examples where they give you the question, they give you the answer, and they give you their thoughts, use the homework helper. It is useful. Your problem set is 3 pages. It's asking you, do these systems have solutions? So use your skills, look at slope-intercept form, compare the slopes, compare the y-intercepts, find out if they are parallel, and if they are parallel, there's no solution. If they are not parallel, there is a solution. And then for number 6, they're asking you to say, is there a solution to this? Is there a solution to if we have a system with these 2 lines, is there a solution? Is there a solution we see? Is there a solution we do not see on this graph? Number 7, they're asking you the same thing. They're just asking you to look at a graph and tell me, is there a solution? Number 8, look at the graph. Tell me, is there a solution? And also remember to explain. Number 9 and 10, same thing, just looking at graphs to decide if there are solutions or if there are not solutions. And remember, my answers to the problem set are all online on the Google Classroom, ready for you to look at, ready for you to check your work with. Use my answer key to help you. Also, remember to ask me questions if you ever have any questions about this, if you get stuck on a question or you just want me to explain it a little bit more. I will help you out. You just have to reach out and ask. But when you feel confident in all this work, when you think you know what you're doing and you've checked all your work on the problem set, then the exit ticket is ready for you. back from page 327. You have 3 questions on the exit ticket. All 3 are the same. Does the system have a solution? And explain why it does, or explain why it does not. And remember, it's all about being parallel, because parallel lines do not have a solution because they never intersect. So use the definition of parallel, use your observation, use your calculation skills to answer the exit ticket. Remember, take a picture of the exit ticket. When it's all done, turn it in so I know that you've mastered this skill. And again, if you have any questions today, make sure you ask. But work hard, persevere, do not give up, do your best, and I'll see you for the next lesson.